Just like velocity is the change in position with respect to time, acceleration is the change in velocity with respect to time. It's one further derivative. So velocity, we'll use yellow, is the change in position with respect to time. Acceleration, A, is the change in velocity with respect to time. It's very easy to confuse these two, velocity and acceleration, but you have to just think of what's changing, what it's referring to. And it just takes some practice. So if we had a path, let's see, if we had a path that was described on a xt plot, so position and time, just like before. And this is our time, this is our position, and the slope would be velocity. And so let's say our path is something like this. Like this, and here, and we go something similar to what we were doing here, right? And then come back. Let's say after that we get a little bit more fancy, and we do some bell curve looking path, like that, yeah? So if we were to plot v versus t, corresponding to the same path here, right? V versus t, we'll set up the same axes, except this is v, and now we have t here. We're looking at the slope of position graph, the derivative of position. And so the slope here is something positive, say like this, and it's pretty constant. And then it goes to 0 in this region. Right? And it's 0 for a while, and then it goes negative at about the same magnitude that it was positive, and it's that for a while, and then it goes back to 0 here. It's 0 for a bit, and then it goes positive again for a short time. And now here, it's steadily increasing. So it's 0 for maybe a second. And it's steadily increasing. So the slope is constantly changing, and it's constantly increasing. So that means we have something like this until you get to the peak. And then it goes, it steadily decreases. Nope. You have it increasing for the first part up to about there, and then it's decreasing. So you have it increasing until you get to that midpoint, and then it decreases, but it's still positive, but it's decreasing, it's getting less positive. And then at this flat part here, right at the top, it crosses 0. And then you go into negative velocity region, and right here at about the midpoint of that inflection, you have it start to decrease in the negative direction. So velocity approaches 0 again. All right, and then what about acceleration? So acceleration of that same path, we'll draw that out. So now this axis is A, and this axis is T. All right, so we have to include some sort of acceleration to get this thing going initially, but if the velocity is actually constant, then there's no acceleration going. So let's say it was already going when it started, but to decrease like this cannot be a perfectly vertical line. A perfectly vertical line would mean infinite acceleration, and that's not possible. It requires infinite energy, infinite force. We'll talk about Newton's second law later. And so this has to have some sort of a non-infinite slope. And so for a brief moment, the acceleration was very negative, but it was 0 before that. It goes very negative. And then here, it goes very negative again for just a brief while, and then it's 0 again, and it goes very positive, and then it's 0 again, and then it goes very positive for a brief moment, 0, very negative for a brief moment, 0, and then this is when it gets interesting. So this portion here is when the velocity is steadily increasing. The way that you steadily increase velocity is you provide some constant acceleration. And so here, the acceleration is something positive for this time, until you get to the peak of that triangle there. And then it goes down to something steady negative. Yeah. And that is maintained the same slope all the way until you get to the bottom there of the zigzag. And then it goes to positive again until, if this continues, if this goes like this, and 0 velocity afterwards, then this would go back to 0. Oops. It would go back to 0 acceleration. Hopefully the lines line up for you okay enough to see that, but it's really useful to look at the difference between x, v, and a for various paths, and to really let it solidify in your mind what the derivatives are that we're talking about. One more time, a is dv dt, and v is dx dt. All right. See you in the next one.